This is the audio notes on solubility for Chem 1. First off, to define solubility, it's the ability to dissolve one substance in another. Again, typically we think of water as our solvent, what's doing the dissolving. So then you have something else that is being dissolved. There are a lot of things that can affect how much you can dissolve. Because again, the ability to dissolve, we're referring to the value of an amount. Temperature is the main one that we're going to go over. However, pressure, surface area, kinetic energy can all affect this as well. Last thing to mention on this first slide is that most substances, when you look at the graph on the right, increase in solubility as temperature increases. Think of it this way: the solvent molecules are moving faster, they're more likely to grab a hold of something and dissolve it. Gases, however, are typically less soluble at higher temperatures. Reason being is gases are already hard to dissolve. A lot of gases are not ionic, they're either very slightly polar or nonpolar, and with that you want to be moving slow to give yourself an opportunity to try to attract and surround it. And the faster the water is moving, the less likely that's to occur. A couple examples I can bring up with this is one: when you open up a can of soda, you'll hear that sound right away. That's carbon dioxide leaving, but there's still some bubbles in the solution. Soda is, after all, a carbonated beverage. If you let that soda sit out on a warm lab bench all day long, the soda is going to go flat. It's going to lose its carbonation because at higher temperatures, gases are less soluble. However, if you put that open can of soda in a refrigerator, it would not go flat as quickly because at lower temperatures, more gas can be dissolved. When referring to solubility, there's three marks of how much you can dissolve. First one is called a saturated solution. If it's a saturated solution, that means you've dissolved as much solute as you could. So, for example, growing up, we used to make Kool-Aid where we would add the sugar to the pitcher, so we just buy the packets of flavoring. And if you kept on adding sugar and mixing it in, at some point you'd reach the point where you couldn't add any more sugar and it would dissolve. So if you keep on adding sugar, it would just sit at the bottom. Once the solution is dissolved as much as it can, that's referred to as a saturated solution. An unsaturated solution means you can still dissolve more solute. So typically when you make Kool-Aid by adding the sugar, you only add 1 or 2 cups of sugar. Trust me, you can add a lot more sugar than that. So normal Kool-Aid is an unsaturated solution. You can still add more. A supersaturated solution is kind of unusual. It's an instance where you have dissolved more solute than you should be able to. So once you write this down, I'm going to go back to the solubility curve and explain what I mean with that to wrap up notes. If we look back at the solubility curve, let's take, for example, sodium nitrate. At 40 degrees Celsius, you can dissolve roughly 105 grams. So if I add 105 grams of sodium nitrate at 40 degrees Celsius, it would all dissolve and I couldn't dissolve anymore. This line is the saturated point. If at 40 degrees Celsius I added 90 grams, I'd be below the line for sodium nitrate. And if that's the case, I'm unsaturated. I could still dissolve more. 105 minus 90, I could dissolve 15 more. It is possible, and next time in class we'll show you how, to make a supersaturated solution, where sodium nitrate at 40 degrees Celsius can dissolve 105 grams. If I can get 120 grams of it dissolved, and it is all dissolved, then I've dissolved more than I should be able to. That's what's referred to as supersaturated, above the curve. What you're going to do right now in class is practice looking at solubility curves and identifying how much can be dissolved at specific temperatures for different substances, and perhaps identifying whether or not a solution is saturated, unsaturated, or supersaturated.